All right, so we are going to continue our notes here. And okay, let's go. So class,
Yes.
Kisnet. Oh, sure. All right, now we're going to use our rules to go back and figure out what this is. We're looking for h prime if f is a composite function of f of g of x in this case. So f of g, that means that it's going to look like this right here. So now I'm going to work my way backwards from this. So of that number, so I need to know what g of x is. So of 1, so I'm looking for 1. So it's supposed to be h prime of 1 is equal to f of g of 1 times g of g prime of 1. Am I missing? Yes, I am. There we go. That's one.
Wait, isn't the F also F prime?
Is it? Yeah, I missed it. Sorry. Man, I'm slacking here today. I have not come close to finishing my coffee yet. That's why. And for those people asking, yes, Kissnet and I made a pot of coffee. So if you brought your cup and you're one of those thirsty, go ahead. So let's see. G prime, not G of 1. Let's start with that. What is G of 1?
2.
It's 2. So what that is, that's going to go into my f prime. So now it's going to be f prime of 2 times g prime of 1. So g prime of 1 is going to give me -3. And so f prime of 2 is going to be -4, which is a grand total of positivo 12. Joseph, you're giving me a crazy look. Is that all right?
Yeah, I was only out.
Oh.
That's what you did.
Okay. All right. So next one, LNs. I already started talking about this one here, so I'm going to erase that for the people following along online, for the few people that actually go back and watch my videos. All right. So when we have the derivative, and this is actually going to be in this form right here with my variable x is now in my power. It's in my power position. It is the exponent. So a has to be greater than 0. A has to be greater than 0, and it cannot equal 1. The reason why it cannot equal 1, let's see, what is 25 to the first power? Okay, that's 25. Now let's work it the other way around. So let's go 1 to the 25th. It's just 1. So that's the reason why A itself cannot equal 1. Because no matter what it is, it's just going to give me 1.
Which would be the derivative is 0.
So I cannot get this one right here because A cannot equal 1 in any of these problems. All right, so, yeah. All right, so let's do the application of this. So in this case, my A value is 2, isn't it? So if my A value is 2, my derivative I could use from the formula that we just had. It's going to be 2 to the x times ln of 2. Joseph agrees.
Morning.
Morning.
Do you need me?
No, not right now. Thank you, though.
Do they
All right, so the next one, slightly complicated, so let's uncomplicate it. What's the complicated part? Negative x. So I'm going to say that u is equal to negative x. U prime is going to equal negative 1, right? So let's rewrite it as 3 to the u would give me 3 to the u ln 3 times u prime.
So that's combining the composite function, or like the ln and the
Yeah,
whatever they.
that's this right here. So we're just taking this and plugging it into this. So that's almost as easy as derivative of e to the x. Yeah, there's a couple other ones that are like just, not really rhyme and reason, just plug them in. Okay, we're going to have some of those, like our inverse tangents later on. Okay, so now let's go ahead and put it back. So put it in. So it's going to be 3 to the negative x ln of 3 times u prime, which is negativo uno.
Why didn't you do that for the other one? Or where did the 2 come from?
Where did the 2 come from?
The probably.
Okay, in my formula,
It's just A.
that's my a, right?
Yeah.
My a is 2, isn't it?
But then why on the other one did you multiply the A by negative 1?
Is this one complicated? This one's slightly complicated where I took and I u'd it, didn't I?
Yeah.
So if I need to u it, it's times u prime.
Why do you need to do it anyways?
Yeah.
It's not even that complicated.
Because
If
it
we
would be
just
the same.
substituted it back
Because it
in
would be
as
the
normal.
same as 2 to the x, except it's just negative. So what changed? Does having a negative suddenly mean that you have to multiply it by u prime?
My formula just says a to the x, doesn't it?
Oh.
It's just a to the x. So anything that varies or change is different than that does not fit exactly into this. So we need to make it fit to look just like that. And because there was something different about it, that's the reason why I did my u prime off of that. Now, would you feel better if I did it again for this one here?
Yeah.
Okay, let's say u is x.
Oh, so then you multiply by 1, so then it wouldn't. Okay.
Yeah, so would that help? Okay. All right, C, I am going to use another paper because I'm going to need a little bit more room on this one. So 1/2 x squared plus 1. So, do we have a complicated part here? Actually, is it a y? No, it's a g of x. What is my complicated part? Okay, so there we go. So I'd say u is equal to x squared plus 1. U prime is 2x. So if I rewrite this now, so my g of x is equal to 1/2 raised to the u.
Then ln of 1/2 times u prime. Right, that's the next step.
Don't forget the first part.
Well, no, I'm saying it'd be 1/2 u times ln.
Oh yeah. I'm sorry. It took me a second to understand. Yeah. Again, I'm kind of slow. Less coffee this morning. So I get 1/2 to the u times ln of 1/2 times u prime.
Is that like it?
Perfect, but there's a slight issue with our LNs and having fractions in the LNs. And this is a rule that I want to actually start emphasizing now. The answer is technically correct once we get to that point. But you're going to have to learn and practice the skill of separating your fraction that's inside your LN.
You could like expand it, right?
Yes, and so give me a second. So it's going to be g prime of x is equal to 1/2 x squared plus 1 times ln of 1/2 times u prime, which is 2x. Now, inside that ln, that 1/2, I could rewrite it. I probably need to really emphasize this because a lot of people just don't know this rule. If it's 1 divided by 2, that means I could separate ln into 2 separate terms. So I could rewrite all this as ln of 1. And since this is a division, go ahead. Minus, very good. ln of 2. Close there. And it's times my 2x on the outside. And bring this 1/2 x squared plus 1. So it's still times over here too. And this is something we're going to use so often. These are things that you should know automatically. What is ln of 1? 0. ln of 1 is 0. Because if I were to graph it, ln actually crosses the x-axis right at 1. So ln of 1. So I don't even remember a lot of the math. You know, a lot of things like e. What number actually e is? It's like 2.7 blah 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 blah. I don't know all that. Okay, pi. Yeah, 3 point. Yeah, we've been. You know, there's more than just those. We have like tau. We have all kinds of other numbers that are represented by symbols. I don't know them all. I don't.
What is ln? Like,
No,
it's
wait,
like
no,
log
let's not get
base
into
e.
Huh?
Let's not get into all
ln?
It's log base e, right?
Yeah, log base e.
Like, what is it?
E is the natural number. Okay? The natural number comes from, we get the summation from so the summation of this from n equals 1 to infinity, and I'm summing up all the terms of this. So as I keep going and I start entering in my numbers, it's going to be like this. It is 1 over 1. 1 factorial is 1. Plus, so it's a summation. And now, what number comes after 1? 2. Okay? 2 factorial is 2 times 1, which is 2, right? Okay? The next one would be 3 factorial, which is 3 times 2 times 1, which is 6. Next one is 4 factorial, which is 4 times 3 times 2 times 1, which is going to give me 24. And so on. So as we start adding these together, and as we keep getting smaller and smaller, because the denominator keeps getting bigger, right? The denominator keeps getting bigger. So if it keeps getting bigger, what is the limit going to be if my denominator goes to infinity?
0.
It's eventually going to add 0, isn't it? Yes? You agree?
Yes.
Okay, but all those infinitesimal little tiny pieces, all those together actually eventually adds up to my 2.7 blah 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 blah.
I figured that out. do that, huh?
I don't know, someone with a lot of, a lot of coffee and a whole lot of, time on their hands. But anyway, so that is like a lot of things in math. It appears a lot. There's patterns in math. So is math created or is it discovered? Fibonacci, the golden ratio. Those things are things that it is in nature. We can map those things because we already know, and we look at the patterns, we see the patterns, and the patterns fit. And there is a numerical value that actually comes up with those. So, that asks the question, is math discovered or is it created? So, I'm on the side of that it is discovered. So we have found that this works all the time, and a lot of the math that we come up with that you see E and natural log, yeah, it just works. It goes together. Simplistic. Kissnet, you had a question?
Is that an infinity symbol on the top? What is that?
Yeah.
Oh,
Yeah, that might, yeah.
that's great.
Okay. Anyway, going back to this. So n to the 1 is 0, right? So I could kind of rewrite this, and this is my rule with my ln here. So I'm going to have that ln, so it's a negative, but it's times all that, right? So it's going to be a negative 2x, right? I'm bringing that over, that there. ln of 2 times 1/2 x squared plus 1. This is my g prime of x. I bet right now you guys think I'm a really smart person, right? Or knowing all this math crap. I'm really not. I'm not. I just recently, I saw this. It was on a T-shirt, and then I had to decode the T-shirt what it says. And I wanted to actually ask you people if you guys want to get math shirts this year with that same saying.
Math shirts?
Math shirts.
What was it saying? Well, that would be
Point.
Oh, I think that would be I N. Okay, I N. I'm. That's so good. 5. There we go. That's what
Okay, so you got the first one right. So I.
And 5.
What did I say this is?
That's natural log.
Not natural log.
It's E, right?
That's what?
E.
Close.
E.
Oh yeah, no, it's just E. You're right. It would just E. It's not E to the X. It's just E.
That's hilarious.
So again, you guys are probably thinking I was kind of smart, knowing those things off the top of my head, and I was just trying to design you guys some math shirts for this year, right? And only other math nerds would.
Yeah, that's gold varsity.
No.
But they never know. Yeah.
Yeah.
It's like an inside joke.
Okay. So anyway. Shh. No one knows how we said this. Anyway.
Yeah,
Oh,
no.
Alright, so power rule for functions define derivatives. If g is differentiable function and n is its integer. So there you go. Power rule, same thing that we've been doing this whole time with my u prime, all that good stuff. Alright, so now, you guys ready? You ready? You ready? You ready? What's my complicated part on my first one? Your mom?
The 3 minus the A.
Yeah. Okay, so I'm going to say that this is going to be u. Hey, shh, shh. Can't talk about it. What's the first rule? Don't talk about it. What's the second rule? Don't talk about it. Yeah, it's Fight Club. Anyway, all right. All right, what's u prime?
Negative 3x squared.
Okay, so now if I rewrite this, this is going to be u to the negative 5, right? So from there, let's take the derivative. That's going to give me of this, of my u.
Negative 5 times u to the negative 6
Times
times
u prime. So I get negative 5. My u, again, is my 3 minus x cubed. And to the negative 6 times u prime, which is a negative 3x squared. Like that. So if anything, I just clean it up a little bit. So that's going to give me what, like positive 15 x squared, 3 minus x cubed, negative 6. All right. Let's pretend you can mental math. Mental math this without writing it down with your u and all that. Yeah, do this one. So think about it. Think about it before you say anything.
times negative sine to the second, or right?
Times u prime.
Times
What you got?
oh, so there's
Just negative sign.
3 cosine to the second times negative sine.
So it's 3 cosine squared theta times
Negative sine 3. Oh no.
negative, just
Yeah.
negative sine theta. So once we actually get into the habit of doing this over and over and over again, and you see the pattern, you can pick out the pattern. You don't need to do it every time. But if you're not that person that could see the pattern, write down all your steps. At some point, it is going to click in these steps. Be like, oh, a chain rule inside, outside. There we go. What's the derivative of the inside, which is going to be the cosine? Negative sine theta. All right, derivative of the outside, so use that exponent. So 3, okay, cosine squared. Anyway. Multiple composite functions, where are we at there? Trying to see how many slides I have left.
Three.
Yeah.
One of them's when we're doing the chain rule for composite.
Yeah. So yeah, let's do B. I want you guys to try B. So you can't do it mentally though. What is the complicated? The quotient rule on the inside. So I'm going to say that's my U. And then U prime is my quotient rule out of that. And when I were to rewrite this, that's just U to the 5th now. This pen's starting to wear out. So continue your problem while I'm writing it down up here. Not really much to combine, just those x squareds. So technically still the right answer. And I could have just left it like this too. If this was a free response question, just leave it like this. Just your setup right here for your quotient will give you the right answer. So that's your +1 for the correct answer. On the AP exam on the free response. But you got to be ready, especially on problems like this, free response, they don't end here. You're going to have to take this answer and do something else with it. And so that's probably where you would end up wanting to clean it up anyway.
The complicated part
Is the inside. Right?
that still isn't.
Yeah, it's really not too complicated. It's
No. If it's the inside, then that's e to the x u to u cubed.
Yeah.
That's still not a to the x.
Yeah, that's not a to the x. So because your exponent's a number, you could just do that number minus 1, right? If this was an x up here, that would be different. That would be an a raised to the x.
Oh, but it's e raised to the x.
But what's the derivative of e to the x? E to the x. So we already know that one right there.
Okay.
So that one right there, it is what it is.
We don't have to use the
Yeah, we have nothing crazy on that one. So, do you want to? I could actually do it for you. I could do the same one. So, if we do that, that would be, so the derivative, so e to the x, if I do it the same way, that's going to give me e to the x ln of e, right? What do we know about ln? Isn't that just log base e? So if that's log base e of e, that gives me what? 1. So it comes out to just being e to the x. Because it's times 1 anyway. So yes, you could use that the same way, but I'm trying not to complicate your life. I think I do that enough of that.
Could we do a real quick though?
Yeah. So e to the x, x squared plus 1 to the third. All right, so
e to the x, x squared plus 1.
so yeah, so it's going to be e to the x times x squared plus 1 to the third, plus, since it's a product rule, derivative of that is going to be 3 x squared plus 1, 2 times the derivative of the inside, which is 2x times e to the x. So there's my g. And then let's just rewrite. So e to the x, x squared plus 1 to the third, plus 6
Is the power rule?
x e to the x, x squared plus 1 squared. I use a product rule and chain rule in there. All right, any other questions? We will continue because we do have a bunch more notes to go along with this. And some more Leibniz notation. So multiple chains. Okay, and multiple practice. So like, share, and subscribe.